Alright, next up we're going to be looking at elimination, which is another technique to solve systems of linear equations. So let's set up a system. Maybe we have y equals x plus 2 and y equals 2x plus 3. So elimination just is adding or subtracting multiples of one equation from another. And the reason you're allowed to do that, first of all, the reason why you're allowed to add or subtract equations from another is because equations mean like both sides are equal, right? So if we subtract y from this side, okay, 0, it should be the same as if we subtract this stuff from this side and get, well, x minus 2x is negative x. 2 minus 3 is negative 1. Because this side and this side are equal. So we're technically subtracting equal things from the equation. Then we can just solve here, plus x to both sides, x equals negative 1. Versus in substitution, then that would just be a little bit more writing. You'd have to write like 2x plus 3 equals x plus 2, and then subtract over to x plus 3 equals 2, and x equals negative 1. Sometimes it's just easier to think about like this, especially if you've got the equations stacked like this, and you can just see it right off the bat. Now, it's not always that easy to just like subtract equations or something. Sometimes you have to multiply first. So I'm going to get rid of this, and then we'll do another example. How about something like 2x plus 4y equals 6, and then x plus 3y equals 2. Well, right now, if we subtract the equations, then there's nothing that cancels out, because like 2 minus 1, that doesn't cancel. 4 minus 3 doesn't cancel. But we can multiply this equation by 2. That way we get a 2x here. So let's multiply by 2. So 2x plus 6y equals 4. And then we'll just write this equation again on top. 2x plus 4y equals 6. Now if we subtract from the x's, we'll cancel. So minus that. The x's cancel. And then we've just got 4y minus 6y. It's negative 2y equals 2. So y equals negative 1. And then we could just plug it back in and solve for x. Another thing we can do is adding equations. I'll just do another example off to the side here. So in a case like x plus y equals 1, and maybe like negative x plus 5y equals 4. We don't have to subtract equations, we can just add them. Because adding or subtracting by the same thing doesn't really matter. So these x's will cancel, because 1x minus 1x just makes 0x. Then we got 1y plus 5y, 6y equal to 5. So y equals 5, 6. Yeah, that's the general idea of elimination here. Why don't we do one more tricky one with not as nice numbers. What if we want to do elimination on 2.4 y plus x equals plus 30.1x equals 2, and say we want to do like 3y plus 2x equals 4. So this is kind of ugly system. I don't really want to substitute in there because that's a lot of multiplication stuff. But why don't, so if we multiply this equation by 10, then we get 24y. If we multiply this equation by 8, then we also get a 24y, and then we can subtract. So if we times 10 here, then we get 24y plus 31x equals 20. Remember that times by 10 is just shifting the decimal place. So when you've got decimals, it helps a lot to multiply things by 10. And then here times 8, we get 24y plus 16x equals 32. Now it's a lot easier to deal with these equations. We can just subtract them like we know how to with the elimination. So 24y minus 24y cancels goodbye. 31x minus 16x, that's 15x. That's equal to 20 minus 32 is negative 12. So x equals negative 12 over 15, which simplifies to negative, divided by 3 is 5, divided by 3 is 4. And then, of course, to solve for y, we'll just go through and do it this time. 3y plus 2 times negative 4 fifths equals 4. 3y minus 8 fifths equals 4. Maybe multiply everything by 5. We get 15y minus 8 equals 20. 15y equals 28. Y equals 28 over 15.